Let's talk about area. Here I've gone ahead and graphed a generic function f of x, somewhat looks like an exponential, and my goal is to find the area that's bounded between that function and the x-axis from a to b. What we can see is that if I shade this in, that would look something like this. So the question is, how do I compute this red area? We can't use geometric shapes at all because this is not a shape that we know. It kind of looks like a trapezoid, but since this is arc, since this is curved, it's a little bit off. One way we might have found the area in the past is to use Riemann sums. So we would add up a finite number of rectangles and figure out an approximation. To get the true value, we would want to do infinitely many rectangles. So what I'm going to go ahead and do is I'm going to use the integral to add up, to accumulate infinitely many rectangles from a to b, and all I need to figure out is what would be inside of the integral. What we see is that the area is going to be given by the integral from a to b of my function f of x dx. What we can do here is we can think of the f of x as essentially the height of the rectangle, and then we can think of this dx, this infinitesimally small width, as the base. So if you're taking a base times a height and you're adding up all of the base times heights from a to b, right, all of the rectangles that are infinitely small, you would imagine that you could compute the full area. Now, how would that look if I went ahead and did this in the y dimension? Well, we could picture our rectangle running horizontally now, where the base and the height of the rectangle would correspond to some infinitesimally small dy right here and some f of y length over here. Our area would therefore be the integral from c to d, our boundary points there, of f of y dy. Now, how do we apply this same logic to find the area between curves?